All right, so ladies and gentlemen, welcome back. Our next video that we're going to kind of cover is talking a little bit about, we're starting to move from the idea of electric force, and now we're kind of moving from that static electricity to focusing on how we can actually harness electricity in a way that's useful for us. Okay, so this video is going to focus a little bit on just some terminology and just a little bit on kind of the transition from the idea of static electricity, rubbing things together, getting a spark, and moving towards kind of continuously having electrons moving, forming what we kind of know as electricity, right? So the first thing is kind of a big idea question, and honestly, it's what is electricity? All right. Now, what I want you to do is just pause the video, take 45, 50 seconds to brainstorm kind of what you think electricity is or what things might be important for electricity. It's really up to you, but just kind of brainstorm a little bit what it is, and we're going to kind of go from there. All right? Take like 45 seconds. All right, so just kind of brainstorming, and I know it's not very easy to brainstorm when you can't really have a nice dialogue about it. But honestly, electricity could be a ton of different things. It could be maybe some, you said things like it could be a spark. It could be something that involves kind of light comes out of the wall, seems to be in those power lines. There are probably more technical terms also that some of you put because you've dealt with electricity, especially if you've been involved in engineering classes. But honestly, for us, all electricity is the idea it's moving charge. All right. And honestly, it's just for our intents and purposes, electricity is electrons moving from one point to another. Okay. Now, that, of course, is an interesting thing because we're talking about the idea of electrons moving, and it seems like it'd be kind of simple to get electrons to move between things. So how come everything isn't electrified, which honestly means it has electricity flowing through it? Okay. And honestly, what we see through that is just the idea that electricity can't flow through everything. All right. And that leads us nicely into talking about kind of just some things that you probably may have talked about in either physical science way back when, maybe in chemistry, all right, but stuff that honestly you probably already have heard these words before, and it's just kind of remind ourselves how they relate to electricity. So we start by talking about the idea of what a conductor is, okay? So some of you might already know what that is. If not, kind of think about it for like 10 seconds. Maybe write down what you think your definition is, and we'll see if we're in agreement or not. All right. So for us, all a conductor is, all right, is basically any material that allows for the easy movement of electrons. All right. So if conductors are basically anything that allows easy movement of electrons, the best type of conductors are usually metal. All right. And pretty much any sort of metal conductor, you have this sort of thing where, you know, electrons can easily move through them. It's what makes them very useful for things like wires. All right. Other materials that involve electricity flowing through them. Now, so what is a conductor? A material that allows electrons to flow easily. Examples, pretty much any sort of metal. All right, those are pretty much the best versions of it. Now, when you have a conductor, all right, its sole purpose is to make sure that electrons can flow through it as quickly as possible. All right, now something that's interesting about conductors, and kind of going back to the idea of the Van der Graaf generator, that's that lightning machine, is that when you have electrons on a conductor, they usually, when I start throwing them on there, they're going to move to the edge of the conductor. And what they're going to do is the electrons are going to spread out on that conductor. If we're talking about kind of that metal sphere, they're going to spread out so that they are as far away from every other electron as can possibly be. All right, so they're not just going to sit on one side, they're going to spread out over the whole conductor. Now, conductors make sense. They're just metal. They're usually pieces of metal. The other opposite type, instead of using a conductor, would be an insulator. All right, and same thing. If a conductor pretty much allows electrons to flow freely, an insulator is going to do the opposite. It's a material that does not allow for the easy movement of electrons. All right, so basically an insulator is anything that's going to make it difficult for electricity to flow through it. Now, insulators can have some very interesting examples, and probably the two easiest ones to see are rubber. Rubber is definitely an insulator. Electrons do not easily flow through it. And wood. Wood also does not conduct electricity well. Okay? Now, for us, that leads nicely kind of into this first little question. So we have conductors and insulators, and just kind of take 45 seconds to kind of write a little response. That why do you think electricians are going to wear rubber gloves when they work with electrical systems? Okay, just take like 45 seconds, just pause the video, give a little answer to that question, and then we'll kind of talk about why it is they do that. All right, so hopefully, as soon as you kind of read they were wearing rubber gloves, immediately you thought about the idea, oh, well, those must be insulating. All right, and the idea that an electrician is going, if they're working with electrical systems, there might be a risk that they might kind of be involved or kind of engaged with electricity. So by wearing rubber gloves, it makes it so that the if they happen to kind of interact with something that is electrified, hopefully the electricity will not be able to flow through them or through the gloves. Okay. Now, of course, if you're an electrician, hopefully you've turned off the power and the electricity so that's not an issue. But just in case, if you're working with live wires, that is a reason why you're going to wear insulating material. Okay. Now, insulators are not magic. They can't perfectly ensure electricity doesn't flow through. Eventually, at a certain point, if I push enough electricity through something, it actually will flow. And that actually causes some very serious problems, because if you start to push electricity through an insulator and eventually you push so much that it actually starts to flow through it, there's so much energy going through that insulator that it starts to melt it, and it usually causes electrical fires. Okay, so that can be a very serious problem. You want to make sure why you don't just assume an insulator is perfect. Now, just for us, just kind of rehash a little bit what we talked about with the static electricity, that when you see a spark, all you're seeing is electrons moving from one point to another. You're seeing electricity, okay? But that electricity is very short-lived. It doesn't last for very long, because once the charge is kind of equalized, it stops flowing because the charges are no longer moving, okay? So for us, we want to think about, and we're starting to move towards this idea, how can we create a system where we can use electricity in a helpful way that isn't just kind of this flash in the pan spark that you see for a very short amount of time and then it's gone. All right, so that's going to be kind of the next step we're going to move into. The next video is going to be an online lab where y'all are going to actually play around and build your first electric circuit. All right, so with that being said, that's where we're going to stop with this particular video. The next video is focusing on circuits. So that being said, I'll talk to y'all later.